Hello and welcome. In this video, we are going to take another look at for loops in Matlab, and specifically, we are going to use a for loop to be able to get the maximum or minimum value from a vector of numeric values. And remember that in Matlab, a vector can be thought of as a one-dimensional array. Now, this video assumes a number of things that you've watched the earlier videos focusing on how to create a vector in Matlab using some of Matlab's functions, as well as some of the basics of how to use a for loop, and also how to combine some logic or an if statement in with a for loop. So to begin with, we want to talk a little bit about what we want to do. We are going to use the rand_i function in this video to create a vector of integers going from 1 up to some maximum value. And once we have that vector of test data or test values, we want to write a simple for loop with some logic inside that will help establish what the maximum, and then later on you can handle the minimum values are in that vector. So to begin with, what we want to do is let's make some notes here, and we're going to use rand_i, and we're going to use rand_i to generate a 1 by n vector of doubles from 1 to I max. And again, there are a couple of different ways that you can use rand_i. We're going to be focusing in on this third overload that simply allows for us to specify the maximum value, and then we get values then from 1 up to that maximum value. And again, we want to capture the max and the min. Now, how are we going to go about doing this? Well, the first thing that we want to do is we want to use rand_i to generate a set of values going from 1 up to 100, and we want to keep this simple or relatively small, and we're just going to do 10. In other words, we're going to generate a 1 by 10 vector of doubles, and I'm going to go ahead and display this down here in the console. You can see then that I have 10 values, and a quick scan will show us that 99 happens to be our maximum value. And again, I'm limiting us to 10 just because it's easy for us to see in this video. We could do this with any number of values. Now, the first thing that we want to do is sort of a little bit of a sanity check, if you would, and that is we're going to use the built-in Matlab function called max, and we just simply want to run this against the Matlab values, the max function, the Matlab max function against the values, and you'll see that, yes, in fact, the maximum value is 99. And so what we'll do here is we'll make a quick note of this. Now, keep in mind, I could run the rand_i function again, and I would get a different set of values, and also you will probably have a different set of values than I will. So don't focus so much on the 99, just focus on the fact that we can easily get the maximum value. But that's not why we're here. We're here to learn how to do this ourselves, because sometimes you will need to write an algorithm or write a for loop that has some sort of logic inside of it. And this is probably one of the simplest examples. So to begin with, what we want to do is we want to set up our for loop. We're going to start off with for value equal to values, and then have our end. And the idea then is that we want to have some sort of variable to be able to hold the results of this algorithm, the results of this process. And we want to have some sort of variable. In this case, we're going to call it current max. And the current max is going to be the maximum value that we have so far found. In other words, basically what we want to do, if you look here at the values, we want to loop through each of these values, and we want to compare it to the largest one that we have yet to find. Now, remember, we're trying to reproduce the Matlab max function, so we don't know that 99 is the largest value. In other words, the first value that we're going to look at is going to be 40. Then we're going to compare 37 to 40, and then 99 to 40, and then 99 is clearly larger than 40, so that becomes our new maximum value. But we still have to continue on because we don't know if, for instance, that we have found a 100 or if there's a 100 in our vector. So the first thing that we want to do is decide what does the current max need to be for a default value. And so your first thought might be make it equal to 0. Well, the problem with that is that for this particular example, I do in fact have a maximum value that is greater than 0. However, though, I could easily set up a vector of values that the maximum value is less than 0. In other words, if you think about it this way, the temperature in Fahrenheit in Antarctica in wintertime would probably be much lower than 0 degrees. And so if we set this up as current max equal to 0, then the default value would appear to be the largest value in the vector, when in fact it doesn't even exist in the vector at all. Well, how do we then fix this and still be able to use this approach? And the easiest thing to do is to set the current max equal to the very first value in the vector. In other words, basically it says that whatever my vector is, I'm going to assume that the largest value in this case is the very first value in that vector. And then from there, we will simply just check all of the rest of the values, looking for ones that are larger. And in order to do that, we simply have an if statement inside of our for loop that checks to see if the current max is less than whatever the value is, or the current value that we are iterating through in our for loop, else, and if it is less than, that means that we have found a new max, else we need to keep looking. Well, what do we do if we have, in fact, found a new max? Well, that's pretty simple. We just simply say our current max is equal to whatever that value is. And then it probably wouldn't be a bad idea to put a display and then just simply display whatever the value is so that we can see the loop running. And again, we can comment this out once we get done. But at the end of our for loop, then what we would like to do is have a display and maybe combine that with an sprintf. And we can have then the max equal to, tell you what, we will keep this consistent here. We'll say current max is equal to, and we know that we are dealing with integers here, but technically they are doubles. And so rather than use the %d, what I would like to do is I would like to actually use my percent, and then I'm going to specify %0f to indicate that I want no values past the decimal point. And I'm just going to print out then my current max. All right, so let's go ahead and run this and let's see what ends up happening. We hopefully should get our 99 back. And sure enough, we get a current max equal to 99. And you probably think we are done. Well, let's take another look at this for loop and to see if this is the best we can do, or if there is an alternate way, or for that matter, is there a problem? Well, you'll notice that if I scroll up here to the top of the output, in other words, the first iteration of this for loop, I am comparing the current max with the first value in the vector. And while on the surface that doesn't seem like a big problem, basically what we're doing, if you go back to the vector itself, because what we've picked as the default value for current max is the first value, we are essentially comparing the first value to itself, which you could argue is an unnecessary comparison. In other words, there's no way that the current max is going to change when you compare it to itself. So how do we fix this minor little problem without completely redoing our approach? Well, it turns out it's not that hard. What we are going to do is we are going to go ahead and rewrite this so that you have both versions of this so you can see the difference. We're going to start off just like we did before with current max is equal to whatever that first value is. That doesn't change. But then what we are going to do is we're going to rewrite this for loop such that we're going to start off with an index value that starts at 1 and it continues all the way to the length of the values. Now, the length of the values will be the length of the vector And in this case, since we're dealing with one-dimensional vectors or one-dimensional arrays, we don't have to worry too much about specifying the size or the orientation. The length will always return us the longest dimension. But we started off the for loop with 1. And essentially, that's the same thing that this earlier for loop does. So how can we get around this? Because remember, there's no reason to compare 40 in this case to itself. Well, what we can simply do is we can select for a starting index 2, and so that we'll start to compare then the second value with whatever the first value is. In this case, that is what we are setting to our current max. And at this point, then it's just some minor changes with respect to the syntax, but fundamentally the logic will stay the same. I am going to go ahead and put another display in here, and we will display the values, parentheses, then the index, and that's just simply gives us some noise on the command line. And now let's look at how our if statement changes. So we'll have our if current max is less than, and before we could just simply say value. This time around, we have to use values. In other words, the entire vector, parentheses, index, else, and if current max is less than whatever the value in that location in the index, the value in that is represented by the current index, if that current max is less than the value at the location specified by the index, then we have a new max. Else, we keep looking. And well, to do this, we simply say current max is going to be equal to our values, parentheses, index. Now, hopefully, if we don't have any typos, we should get the exact same results. And to prove that, I'm simply going to copy and paste the final display in the sprintf. Again, you can kind of ignore that warning recommendation, or you can use fprintf. But if we run now this second section, you'll see that we do, in fact, get the same result. The current max is equal to 99. However, with the big difference being is we are not comparing the first value to itself unnecessarily. So hopefully this video made sense. Hopefully they found this useful. If you've got any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.